Okay, so for the last video in this first series of videos, I want to actually give you a little bit of a head start or a kickstart on Worksheet 2A. So I've got Worksheet 2A here in front of us, and you can go ahead and do this first section here on your own. You can Google definitions of quantitative and qualitative and figure that out for yourself, so you can write definitions in your own words. Whatever words make sense to you is fine. And then you can go ahead and go through this information and decide which one seems like it's more qualitative or more quantitative. What I want to get started with you is just go through the rest or the next few sections and do an example for you so you see what it looks like. So this first one is pretty straightforward. All we're asking you to do in part B is round off each number to whatever digit is underlined. So we need to write this number rounded to the tenths place. So it'll be 876 point, and since the next digit is a 5, it rounds that one up to 6, 876.6. Here we're rounding off to the ones place, so 76 to 76, and the number's done. Because the 0.2 is less than 5, so it doesn't round it up to 77, it just stops at 76. So that should make pretty much sense. We've been doing that since elementary school, so you should be good with that one. The next one is about writing numbers in scientific notation or decimal notation. So to do this one, I don't know if you've done scientific notation or decimal notation before. We can talk about it more in class. But this is an example of scientific notation. What this means is 10 to the third power. 10 to the third power is 1,000. That means the real number is 1,000 times bigger than this number. And the easy way to deal with this is the digit up here tells you how many places to move the decimal place. So this one, 2.738 times 10 to the third power, will move the decimal place 3 places over to make a bigger number. When it's negative exponents, the thing to remember is a negative exponent means we're making a smaller number. So you need to move the decimal in the direction that makes it a smaller number, which would be this direction. So let's try this. Move the decimal place over 1, 2, 3 places. We have 2,738 is the number in regular notation or decimal notation. Here we need to move the decimal place over 2 places, but to make a smaller number because it's a negative exponent. So it'll be 2 places in this direction. So if we were to fill in those numbers, it would be 0.09213, and that's what we'll write in over here, 0.09213. That's pretty much it. If we go back up here to the ones that are already written in decimal notation, we just do the reverse. It's 1, 2, 3 places to get the decimal point after the first number, so we're going to write 2.76. We moved it over 1, 2, 3 places, so we write 10 times 10 to the third power, and since this is a number smaller than 1, a small number, we use a negative exponent. This is a number bigger than 1, so in that case we use positive exponents. We need to move it over 1, 2 places to get behind the first digit, so we get 5.193 times 10 to the 1, 2 powers. We use a positive exponent because this number was a number bigger than 0. So that's it. Go ahead and try the same thing with these numbers over here. On this next page, now we're actually doing what we talked about in the first video, where we're reading a thermometer. So you should be able to go ahead and do that. If you need to go back and review that first video, go ahead and do that, and you can just tell what temperature you think it is on this thermometer. Next, we're asking ourselves to circle the estimated digit. Remember that in a measurement, the last digit is always the estimated digit. So this is pretty straightforward. The final digit is the estimated digit, so there you go. You should be able to complete that through the course of this exercise. Then the next one is calculating significant figures or precision. Remember that significant figures is what we count when we're doing multiplication or division operations. We count significant figures, and precision is what we count when we're doing addition or subtraction operations. Significant figures, you literally just count the number of digits, 1, 2, 3. Precision, you look at what decimal place or what place the last digit is in. So in this case, the last digit is in the tenths, hundredths, thousandths place. So you can record that. Either you could write the word thousandths, which is pretty cumbersome, or you can do what I'd probably recommend and write plus or minus 0.001, and that would just be showing the place where that last digit is, showing that it's in the tenths, hundredths, thousandths place, the third decimal place, 1, 2, 3. So if we were to do it again for this one, we'd go 1, 2, 3, 4 digits, and it's in the 1 or the tenths, hundredths, thousandths place, so we're going to write plus or minus 0.001 to show what the last what place the last digit is in. Now there's a couple things with this. We need to talk, and we will talk about in class, about exact numbers. Exact numbers have infinite significant digits. And that's because they're things that can be counted exactly, like people. If there are 10 people in a room, it's not possible that there's 10.5 people in a room. You can't have a 0.5 person. Either someone is a person or they're not a person. There's no such thing as half of a person. So in that case, we would call the precision on that exact. That's not something that you're using a thermometer to measure that would have a set precision of the measurement. You can actually count that. So that's an exact number. It would have infinite precision and infinite significant digits. And the other thing that we need to deal with is zeros in counting significant digits or significant figures. It means the same thing. And that we'll actually go ahead and talk about in class. So as you do this, let's do it. Make sure and do it in pencil so that you can correct the ones that we find that we need to count differently depending on the zeros. All right, let's go ahead and look at one more, or actually, I'm sorry, two more exercises to get you started. So this one is asking us to round to the indicated number of significant figures. So this one's asking us to round to 4 significant figures. So starting at the left here, you just count off 1, 2, 3, 4 significant figures, 1, 2, 3, 4, and round to that place. So 876.6. So just like the previous rounding exercise, you're just rounding. It's just telling you in sig figs how many to round to, not underlining the rounded place. So just count over 1, 2 places for 2 sig figs and round to that place. Then on the next one, we're going to do it on precision. So same drill. Make sure you round off to the place that's indicated. So round off to the second decimal place, which we call the hundredths place. So start at the decimal, tenths, hundredths place. The second decimal place is where we'll round off. This one's going to get a little dicey because this one needs to be rounded up. So when that rounds up, that'll go to 0, which is 9 rounds up to 10, which will have a 0 in that place, which rounds a 1 up there, it rounds it up to 10. And you're going to get 680.00, with the last digit then being in the second decimal place, just like we were told to round to. All right, so that should get you a pretty good start on Worksheet 2A. Happy studying.